Yeah, it is the inner, but why are we letting it equal to that? Sometimes it will be the outer too. Sometimes it'll be something else. Hold on. Whoa. Hold on a second. There. All right. Now let's try this again. Let me ask my question first. Why? So we let x.
What?
He just answered it for us. Okay.
So we let u equal to x squared because you notice that there is a 2x in the problem. Yeah? Right? I'm not letting it equal to cosine because there's no sine in the problem. I'm not letting it equal to 2x because there's no just 2 by itself. Does that make sense? Mm-hmm. You want it to equal to something where when I take the derivative of it, it somewhat resembles another function that's there. Okay? So when I say that, by the way, I mean that if I take the derivative of this, right, this is going to become du is equal to 2x. And I've been cheating a little bit here. Remember this? It's technically du over dx, right, is equal to 2x. Yeah. But I've been cheating a little bit because we're going to do some algebra to solve for dx. So I've just been kind of putting the dx at the end of this side over here, right? It's called we call those differential equations. Basically, you have a delta something and a delta something else, and you just put them on different sides of the equations. And we're going to do those types of problems in the next unit. But for right now, just kind of know that I'm kind of cheating a little bit. It's technically not supposed to be under on this side by itself. It's supposed to be underneath over here, right? And I'm just doing the algebra and multiplying it over for us, just for us to be a little bit easier with this. Okay? Now, how does u substitution work? Is basically this. Once you get to here, you want to solve for dx and get dx by itself. Meaning, I need to get rid of the what?
2x.
So this is going to become? Good. I'll get du over 2x is equal to dx. Notice now, this is where I can start substituting. This is called the u substitution method, by the way, because you just start substituting stuff out, right? So check this out. What's x squared equal to? U. So instead of writing x squared, I can just write the letter what? U in there. Instead of dx, what can I write instead? Du over 2x. I can replace those two things. Yeah? Now what's nice about this is when we start solving this out, integral of 2x cosine of u, and instead of dx, it's going to be du over 2x. What happens with the two x's? They cancel out. You end up with the integral of cosine of u du. You know you've done this correctly when all the previous variables are gone. U substitution is a beautiful method in the sense that you know you messed up if there's still an x involved. Just like in your life, if there's still an x around, you've done messed up.
Oh,
Yeah.
I get it.
Yes.
Life lesson.
That's so late.
Life lesson, Lila.
So, whoa.
Damn.
Call her out.
Makes sense.
Oh my God. Okay. Okay.
Actually makes
Okay.
sense.
So, when you look at this integral, when you look at
Can
this,
I use the restroom?
when you look at this integral,
Just gonna, yeah.
when you look at this integral now, don't worry that it's the letter u and du. It's still going to be treated the same way as x and dx, right? What's the antiderivative of cosine? Sine. Very good. So this will be sine, but instead of sine of x, sine of u. And look, there's no numbers up here, meaning I'm not doing this from a to b. So what should I make sure I add at the end here? Plus c. So this would be sine of u plus c. C.
That's the answer?
Almost.
Oh.
Put it back to its original.
Yeah, so we know that u was originally something else, wasn't it?
Yeah, it was x squared.
X squared. So my full answer is going to be sine of x squared plus c. Okay? That is it.
Great.
We try another one.
Yes, of course, but before we try another one, I want you to see this. The original problem was what? The integral of 2x cosine of x squared. Yes?
Yeah.
You can always double check if what you did was correct. And it's actually something I would ask you to practice because we haven't done chain rule in a very long time for derivatives.
I never knew how to do it.
Well, we did it with the other one that you chose.
I was always stuck.
So let's take the derivative of this real quick to see, does it equal back to where we start? So let's check this out. What's the inner?
Inner is x squared.
And the derivative of x squared?
2x.
Beautiful. What's the outer function? Sine of some stuff, which is going to be cosine of some stuff. So when I take this derivative, this is going to come out to be 2x times cosine of some stuff. Does it match?
Yes.
That means this is the antiderivative.
What's the c doing?
What's the derivative of a constant?
0. Nothing.
Ta-da!
Hey, let me teach you how to write fast.
For real.
Slow it down. You can take the time right now to write.
Do you mind if you scroll up a little bit so I can pull up on my
That's why you record the whole lesson.
There you go.
I think sounds like we're recording like that. Wait, what? I'm gonna do that in college. Record the whole lesson on my phone.
It's not open.
I'm
I'ma
just
just-
there so fast.
I'ma just wait.
So you're just gonna carry the pass in your hand?
Yeah, I'ma just wait and leave it here.
Understandable. Understandable.
All right, you guys ready to try one on your own?
Yes.
Yes.
So ready.
You want an easy one or a hard one?
Hard.
Can we get a
No.
medium?
can we do
A
it?
medium?
Okay,
Yeah,
medium.
can we do like
Can we get, this is my first time doing it.
Yeah, exactly, exactly.
All right. Let's do an easy one first, and then I'll put a
The challenge one.
challenge one next to it. Okay. So let's go with. How hard do you want this? Let's see. How easy are you gonna make this, Nakmi?
How hard do you want it? I'm
Oh
sorry.
my God, just can't pay attention.
All right. Let's see.
Sound like Jasmine.
For not me. Are you recording?
Uh huh.
Oh.
Let me see
I'm
here.
ready for it.
You know what, Lila?
All right. Hold on a second.
I mean, I get kind of zoom into history month, but sheesh.
What are you trying to say?
Sheesh.
Right, you trying to say we're more, you know what, history?
It seems like Lila.
Actually,
I
I'm.
think this is what
say
you should
we
like.
are mathematicians right now.
Right. What are we talking
All right.
Like, 'cause that was calculated, huh, Lila?
Not at all.
All right, let's do an easy one for you. Let's go with 6x squared over 2x cubed plus 1 to the fourth power dx.
Oh, yeah,
Lila's like, I have to go.
it's a B.
That's the easy one.
Oh.
Here, if you want, let's take a look at a more difficult one.
Mine.
The hard one has your favorite type of functions,
Tricks.
right?
Yeah.
We got here sine to the 10th power
Something is itching my
of 3x
10.
times cosine of 3x dx. Here are your two problems to try. The one on the left is actually easier.
Uh-huh.
I take it back. I think they're equally the same. But
They're
your aversion to trig functions might make the second one look harder.
Oh wait, 2x to the third is 6x squared. Wait, no, it's not.
The derivative.
Oh yes, it is. Wait.
Yeah.
Oh yeah.
Work it out.
So it's the
So that's the derivative.
Wait. So it's gonna.
Try
is
it.
it gonna be?
Wait, but
Try
what
it.
happens to the fourth?
Estoy
Try it.
confused.
Oh, we use 2x cubed as our u.
But but
Work
the
it all the way
is-
through. Let it go. Come on. Come on.
Plus
I
one?
have a question about it.
No.
Keep
Yes?
going. Keep going. Just try it.
I don't want to be wrong.
What the one that
I-
also includes
I
because you solved for it, you still did.
Oh, because even if you use plus one, you take the derivative. And that's okay.
Mm-hmm. Look at you, still being afraid of commitment.
I still am.
Wow.
With multiple things.
Come on.
Poor Lila.
I know. Why are you guys hating on me today?
We're just being honest today.
I know, man.
It's not our fault.
Honesty is the best policy, I guess.
Honesty TBH.
Plus makes me all hot.
To be rude.
It's hot outside. Oh, what am I doing? Oh yeah.
Hey, then
What are
another
we
question.
what are we
So,
letting you equals
The
No,
cube
no,
plus one.
2x cubed.
equals to x.
Right, but I have another question. When we had
Oh
to
yeah,
do that,
replace this whole thing, and you can replace the dx with this. Check out what happens when you do.
So, I replace this with.
Yep. So the what? Good. Replace the dx with that.
Wait, what?
How do you find the integral?
It's one of those things that you can like.
Have you got it?
Yeah.
What?
Yeah. Okay, see, I don't have all the steps written down.
Notes just on my phone.
Wait.
How do you erase it?
You use water and.
Where did you go?
Oh.
And is these special? Are these special pens or are they just?
They're like friction
Oh, well.
pens, so like I can use it on paper and erase
Oh,
it.
wait.
Take away what? Oh, that's awesome. Oh, what world we live in.
Busy.
Sorry, go back to work.
Knock me, is this the answer?
Look at the U in the bottom. Isn't technically U on the
confused.
border?
How many is it? Help me. Knock
You did the
me.
U substitution perfectly. That's a good job. We'll work on the integral part together if you're stuck on that. But the U substitution, perfect.
Okay.
You want to try the second one?
Oh, because it's D. Okay.
So that's the answer?
Well, then we still got to do the integral. But the U substitution part, you're done with that. You still got to do the antiderivative of that.
Is this right?
I don't even know if this last part is correct or if
I don't
there's-
understand.
or if they're supposed to be multiplied. I don't know. Okay.
Oh, you're so
Yeah,
close.
because we got See, but I don't know how to figure the integral or the integral out.
First of all, the antiderivative of U to the fourth.
Oh, antiderivative.
Can
Second.
I see?
Where's the U to the fourth? Is it in the numerator or the denominator?
It's not.
You can't call this a number.
It should be canceled, right? So that should be 1 over U to the fourth.
Wait.
Think about fractions.
Oh, because this is a
Yeah, that's what I was
Wait,
thinking.
hold up. Knock me, you're confusing me.
Looking good?
Oh, right. Yeah. Everything would just be one on top, right?
That's what you got to figure out. But your U substitution is spotless.
Once
It's perfect.
And then I was left with U plus 1.
So
I don't know if I'm doing it right, but that's correct.
You just plug it back in. You haven't done the antiderivative yet.
Alright, so what's number 2?
You know what I mean? Like earlier when we did like
I'm just solving.
x squared, the antiderivative of x squared was x to the third over 3, right?
I got stuck on
You
here.
have to do something with that U to the fourth. Uh-huh. Do the antiderivative of that.
Okay, solve for two.
Wait, not
Yeah,
me.
yeah, yeah.
Like, you
Alright,
substitute.
how do you want it?
Just divide.
I'll do this.
I'm so close. Cancel that, cancel that out. You replace it with a U. You can't do that.
6x squared. You're just
How do I-
That's why I think it would have been better if you let U equal to the entire thing with the plus 1. So then you could replace the entire thing with just a U, so you don't have to deal with plus 1. And it would just be U to the fourth.
What?
U to the 4th, right?
But U to the
Divide
fourth
by
would be in
this
the
term, so
denominator.
it's 6x squared, not 6x.
Which would be 1 over
Wait,
U.
what do you mean?
how do you
But
how
you
do
solve
the
it,
yeah.
antiderivative of that?
Divide
Cancel
6x squared to
Of
get
1 over
x
U
by
X
7.
squared over
Oh.
U. The 6x's
You can do
cancel
it
out.
that way, but it's on the right
Oh,
side.
you're right.
X
So
is
1
next.
over.
It's under 1 though, isn't it?
Dx is
Oh.
1 over that.
Okay.
Cancels it out.
now.
Under
Do
1.
this again.
Also, you should have let U equal to
That's a fraction.
Instead of
Okay, so
2x
then.
cubed plus 1. That way you don't have to deal with
You're
this
gonna go to
monstrosity of a plus 1 to the
Substitute
4th.
U.
You would just have to deal with just 2
This,
to the 4th.
we know that it's equal to u. So
So it's 2x plus 2x cubed plus 1. You can substitute out that entire thing.
What if
so
we
you don't have to deal
just-
with plus 1 anymore.
What if you?
And then on top of here, it's like this.
Neutral. The antiderivative, you're good at that.
Back to the top where you said U is equal to
du
2x
over
cubed.
u.
Put 2x
1
cubed
over
plus
U
1.
to the fourth.
No, 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 no.
How did you get 1?
That's why I just got.
Isn't it? She immediately
No.
Times.
Because then what's the integral of
Substitute
that? You
dx.
still have to deal with the integral. You can't just,
Since
you can't just look through that, but I don't know what the integral of that is.
No, no. You know, this is dx. So substitute this. Because you're trying to get u's and get rid of x's.
Something you need to figure
you're up.
No.
I'm not good with that. Well, it's fractions.
Mm.
Times d of x, right? Times. No. How do you erase?
What did you do?
I just keep you that.
What happened?
You're wrong.
1 over u.
I'm wrong?
D.
One over u to the
Yeah,
fourth.
I know. Times.
Oh yes, it is still 2.5.
It's gonna be d of x.
It's the same thing.
Except that you know what d of x is in terms of u. So you're gonna substitute
And
it.
this. You know that like derivative of 1 over u to the fourth?
Substitute it.
I got
You're trying to times it times d of x, but you know that you just solve for d of x.
This is not five.
Yeah.
Well, no, but
So now-
I haven't asked them because well,
Antiderivative of this.
2x third
U
times
to
to the fourth. You just add that.
Now you're trying to solve this from that.
Cosine is negative.
I really did add it, but
Yeah, what is antiderivative?
Negative
when you like do
Exactly.
u to the fourth, it's 2x.
Not
I like what you're thinking though. You're not picking the 3x.
How did you get
A
that?
lot of students will pick 3x. You don't want that one. You want one of the trig functions.
How is it one?
Well, that didn't work.
Integrate.
How?
Some techniques or some strategies, some properties that we learn.
What? Oh. Yeah, okay. That makes sense.
Oh my.
The antiderivative of that.
See, what I did is I just like.
Oh, you just built a u on the top.
But it's like.
Natalie.
How do you say it like that?
Why did that sound like?
Madeline?
See, I.
No, that sounded like a song.
It was Natalie.
Yeah.
Valerie.
No,
So my question is,
Yeah.
how
that's not the song I'm thinking.
Yeah, it's Valerie.
add them together?
That's not the song I'm thinking of. I'm gonna say yes, it's that. That's not the one I'm thinking of.
It is the song, Nafi.
It's not the song I'm thinking of.
It's a song.
So
I was thinking of Outcast.
Yeah, well, no, that's the antiderivative of that.
I forgot the name of the song.
So it's not.
Navi,
It's gonna bog me. What's
how
up?
do you take an antiderivative
But
of fraction?
this is the
Can you just do that on the board? 1 over u to the fourth. Just do that.
So u equals the antiderivative.
Wait, why is it 1?
Cross it out.
It could be d.
The antiderivative basically.
Yeah, but it's that.
Oh, what?
Huge.
What do you think you got?
Because when you cancel out the 6x squares, there's still a 1 at the top.
1 over u.
So close.
Would it be 5?
Right? And then u equals.
I'll give you a hint. I'll give you a hint. Let me give you a hint. You ready for a hint?
Right?
No. Yes.
Gotcha.
So you just
Oh, see, you substituted it in, you make it different.
That's what I tried to do.
Is it
but I
5?
got stuck. I was like,
Is it 5?
Is it looking the same as that?
Since you know what
Yes.
u is, you substitute.
Yes, it is because you're just
No, no, no.
substituting the x
You
for
solve
the u.
it.
Wait,
And
it's
then
x to the negative fourth. I mean,
Exactly.
it's u to
And so
the
the only thing I'm
negative
confused
fourth.
about is
Why
what
did-
you-
Because when it's a negative exponent, then you
fraction.
include the
Oh,
fraction.
Wait.
Hey,
That's what I tried doing, but I did it wrong.
Or could it be?
I put u to the fourth.
Give me one.
Or could it be
Negative four.
to the fifth?
Because the negative exponent becomes a fraction.
Wait, explain it again.
Okay, so now like whenever you have
Right.
What did you say, Will?
It's 2. D again.
U to the negative fourth. Hey, we have negative exponent, it becomes a fraction.
Okay, then you can just do that one. Okay,
That's
so
it.
we're trying.
No.
See, that makes sense.
Rewriting it into a power that makes it easier to do the integral is going to be the trick for this one.
Okay.
So it's 1 over u to the fourth, right? Rewrite it as a power. Meaning,
Hey, that's right.
if I had 1 over x
Wait,
squared.
so what is it?
Rewrite that for me.
U to
What would that look like
oh,
with
so
just exponents?
it's gonna be 2x cubed plus 1 to the negative 4.
2x cubed plus what?
1, and obviously parentheses around that, to the negative 4.
Remember that? Apply that to this
Wait,
problem.
what? Let me see.
Aren't you supposed to take the
Let me see.
antiderivative?
That's the answer to, oh shit.
The antiderivative would be u to the
Wait.
negative third over negative 3.
No, but what if,
E.
is this the antiderivative of that?
No.
No.
That's
No?
just a simplification.
Oh.
So you have you still have to do the antiderivative.
What the hell is that?
It's on there on the board. So
What did you
since you
add?
have x to the n,
Oh.
n is negative 4 plus 1, that's negative 3, then over negative 3. So it's u
I
negative
don't think
third
they would.
over negative 3.
No, they don't
Ta-da.
cancel out. You can't cancel out.
But it won't do that.
Why not?
Because if you,
So isn't it just
negative
u?
4 plus 1 is
I think this is the answer. Isn't it just u?
Yeah.
U to the negative third power over negative 3?
So
Yeah.
that's u.
That's
Plus-
it, right?
But you
Plus
have to
C.
substitute the
Plus
x
c,
back
plus
in.
c, plus c. have to
substitute
substitute
You have to
the U.
plug
The
in.
U. Oh, okay, great. Alright, alright. Gotcha. I'm on the roll. I think.
Wait,
And you don't have to simplify, right? Not me. You don't have to just plug in and you're done. Okay.
got it.
That wasn't so bad.
Okay, I can find it.
And Miss Tanaka, you said we don't have to include the 1, right?
So the U here.
With our U because.
For first of all, no.
I was
Yes,
saying
but
U
like
should
no.
equal
He literally said that's right.
It is, but
x squared plus 1.
okay. Anyways,
No, I like the other way. It makes
Oh,
more
wait, no,
sense
no.
to me.
this is wrong regardless.
The other way it made more
So
sense to me.
our
Okay,
U
fine.
equals the whole thing.
Stop.
For the second one, is it gonna be like
Stop.
the derivative of sinus cosine?
Literally, you could probably see it right here. My train of thought was u
that
to
three?
the negative fourth, and then I did it like this, and then I put du, and I was gonna try to do it that way. Similar thought process, but not the right technique.
That would just turn it
Now
into a
what you
plus
just have
4,
to do-
right?
Wait.
Oh, you chain roll.
Which we're not allowed to just change things around just to
I
make
mean,
it easier
how
for
would
our
it?
lives.
How would it?
Where's your U?
Because you chain roll it.
Well,
Now
no, it's
you
still
would
what
say
it
x
made it negative.
Okay, so
Q plus
you
1.
converted to this, but that doesn't mean you integrated it.
Oh, I don't
You
know.
just simplified it so that
For
we
the
can
second
do
one,
it.
what would it
It's not
be?
just
Sine
x.
stuff?
Because you know what U is equal to.
Then
That's
what's
not
the
integral. That is just
Cosine is
simplified
derivative
version of
of
that.
cosine is derivative of
U
sine
to the
is
negative
sine
4th is the same as 1 over u to the 4th.
But it, would
Doesn't
it
mean
be
you did
just
the
sine
answer.
stuff?
I know you have to chain roll now.
Cause I know what the
Did you
I
get
thought
it,
you
Dennis?
did.
I got, you got the answer?
Yeah.
The negative third over.
Yeah,
Oh,
make-
yeah,
no,
it's what
just-
you got. Yeah.
It's, you have to chain roll, right?
General what?
Okay, I can just leave it like that?
Yeah.
Oh, what?
Okay, here, is it just gonna sine stuff or the 10 as well, or is it just sine stuff? I don't know if the 10, not me.
What do you think? If you just do it, just
Cause you
sinus.
can't put 10 because 10 doesn't make
No,
that close,
I'm
so
stuck.
it's just sine
Yeah.
stuff.
I know how to get my computer. Okay, let's do the last one.
Have you do the both or just one? Beautiful. You
Oh,
simplified it.
Jasmine, what was that?
So-
Oh my god.
I'm just saying you put it down at the bottom.
Think of an exponent that is the same like
Like I would have, you would have been the as well as put 2x cubed plus 1 to the
Do
negative
you
third
know of an
power.
exponent that's here?
But this is perfect. It's like,
No,
there's
the
nothing
10's
wrong
not
with
involved in
it.
anything.
Yeah. Or if you were just simple, like this is simple.
That is the rules for,
So, like,
because they made a
for example,
rule that a lot of teachers just like, you can't do that. In reality, no. But pre-calculus, there's a lot of made up rules. There was that rule, there was the rules that you can't use like square roots, if you simplify it. People used to say you can't
So
have the
you
square
would
root of 50.
have one
They want you to write it as,
over u
they want you to write it as 5 squared root of 2 because
Since
that's
you have
more
this up here, that
clean.
means that you basically have
They're the
this
same thing.
to the negative 1 power. So you have u,
It would just be negative cosine
negative 1.
something, right?
These
Or
can
it
just
could be.
multiply together.
You could do that one. I wouldn't do that.
Oh, so wait, what?
Guys,
Wait, no.
It'll be
You
3x.
include 3x, right?
Yeah, so you would
So
like
how come on this
from
one
here,
it was, or
you
no,
would make it
the other one?
u to the
Yeah, why didn't we use the trig function on the other one?
That's just
Why did we
simplifying.
use
There's no
the
derivative.
side?
So you're just simplifying.
Oh, because it was just the stuff that's inside that was.
That had derivative.
Because of the negative 1 exponent assumption.
Yeah.
Get to
It's not.
So we can do
Yeah, so after you simplify, because you have to simplify the
Well, what does
fact that
negative
there's a fraction here, because we can't take the derivative of a fraction yet. Because you understand.
Where's the
So you
exponent?
just want to
Where's the
simplify.
exponent?
That's where it turns into
Parentheses around that?
right up
To the negative 2?
it turns into u.
That's the answer? Okay, cool.
So that's just that, right? That's for the step. Then after that, you see that equation that you wrote on the board? Then you
Batman, have you
just
watched Batman?
so now that you have u to the negative 4, take the antiderivative.
No, because rewrite this one, right? Integral? Integral
That equation on the board is what
u to
so
the negative
basically
du.
the x
No.
and then
It was this. This is a problem, yeah.
So we're going in.
Is the antiderivative of sine to the 10?
That's it.
over
Is the antiderivative of this?
And
That's still
the
horrible.
pen is like out, like
Yeah.
reaching outside
What
of
is
the tablet.
knocking? What is that?
The equation.
Better.
Knocking.
Actually, I think it's
But it's like off the
This?
desk too. So it's kind of like.
Knocking.
Oh yeah, that's better.
Yeah, much better.
So because it's uniform,
And then all the entire desk.
That's just also crooked.
Knock me, you know there's no way that I'll be straight.
Shut up. Oh gosh. Yeah, no, that's not happening. Are you taking the antiderivative of sine 10
Oh, yeah.
or sine 10 to 3x? And I'll know the antiderivative.
Why didn't you let u equal to sine, right? Why is there still sine? Why didn't you replace it with u?
Oh, wait. Oh, but then what's the antiderivative of cos?
Oh, I messed up big time.
no. I forgot about that one.
I tried to do the U,
So what is?
but
Where's the d?
Yeah, sorry.
Replacing the
I don't know, I would have to figure it out.
Or
Do you cosine?
cosine of what?
What would it be minus?
I don't know. I just thought it was big time.
Here's an issue. What's the
Oh,
stuff
it'd
that's
just
in
be
there?
3 times cosine
3x.
That's
Wait,
not
go away.
I need a
So this is gonna be cosine of 3x. Because derivative of sine of 3x will be cosine of 3x. But you gotta change rule this derivative, don't you?
Okay, I'm confused. So all of this is wrong? So then what do you do chain
All
rule?
of it is missing something.
So before I do this, I have to chain rule?
Because the derivative of sine is cosine. So what's the derivative of the inside side?
3. And
This
then
will be
what's...
3 cosine of x. So then it'll be a
Okay, now we have to do this.
Not all, just put a 3 inside. 3x inside.
Well, I need to show my chain rule.
Beautiful. But what's the derivative of your 3x? There we go.
isn't it negative
That's
cosine?
the chain rule with it, right?
Oh, no, the derivative of cosine is the negative sign.
But then the derivative of sine is
Right?
just cosine.
Always got a chain rule if you're gonna take a derivative of things.
Wait, so for the second one, is this how we would like to proceed?
What?
The antiderivative of sine
It's negative.
That's not a bad idea, but I have no idea how to integrate that because it's still a product rule, isn't it?
So then why?
And integrals don't
So
have
then
product
it's
rules.
3
So
cosine
we
3x.
gotta try to use something, use something else.
Is that a negative?
Listen.
Okay.
So apparently the u is not 3x. It's sine of sine is 7. Really?
Sine of 3x,
Oh my
yeah.
god.
That's,
Why didn't you?
That makes
Because
no
your
sense.
d of u is
I was
3
like,
cosine of 3x.
sine, then it now would
Does it
But I
have
have
to
a
do with
question
that?
for that.
Wait, sine
So
of
I'm
sine of
gonna-
3x?
And that would be different, but because
It's
this
after
is an after 10.
Is it
anything.
stays there.
Huh? Yeah.
So
I'm
I'm
glad
I
we're
don't
gonna do
know,
it just
do
like
you?
the 10. I'm just gonna leave it
No,
there.
I'm leaving the
So then,
The 10 goes in with you, right?
tango.
And then you have your D, your
Because it's sine to the 10th power, right?
Yeah.
So we're replacing sine.
For the derivative
So
of
it's gonna be u to the 10th
Oh,
power.
yeah, right.
Okay.
Wait, that's a negative right
For the
there?
derivative
Oh,
of u,
negative cosine.
it's
No,
3
it's
times
We'll
not
figure it out.
four,
We'll
it's
figure it out.
negative cosine 3x.
Huh?
yeah.
Chain rule.
So knocking.
Chain rule never goes away.
Sine to the 10th.
Also, don't let u equal to sine to the 10th. Just sine of 3x.
Okay, okay, okay.
We'll deal with the 10th
Here.
later.
I just have
Deal with the 10th
this.
later. No, but u equal to sine of 3x.
I did the u yet. You did u
Sine of 3x.
because you cancel out.
No. X
3 cos,
squared
you cancel out
times
cos.
negative cosine.
Not x
So
squared.
you get this, right?
Not x cubed. It's
3 cos.
Not x cubed.
x cubed times
right.
negative sine of x
And then you plug
squared.
that in for
What?
the cosine.
It's not chain rule?
What's the antiderivative
Yeah, this
of
chain rule.
10?
Then it's
So left. So
Oh.
What's the derivative of 3x?
3. What the heck?
Derivative of 3x is just 3.
Yeah, I need to do the change.
Yeah, see,
So
I'm getting
now-
Right after chain rule.
I'm trying to
What's
figure
the
out
inner
how
function? What's the outer function?
like this.
And then that'll get you your du.
Because I think it, is it,
Because I'm
Knocking, is this,
terrible with
this,
changing
I'm so
things, I can't
confused.
remember.
I feel like this is
Uh,
wrong.
The derivative of
This
3x
was
was
right.
Okay, and then this,
This is right.
okay.
is it u
But then how do
You
you
think
like
it's terrible at
subtract
that.
this?
I feel like this is wrong.
It's confusing. I don't know.
You know,
I don't know if this is right.
I've never seen you at tutoring.
So
So you were able to.
Yeah,
You got the
very
two
true.
Why is that?
Wait, then
I know
I feel like
that
this
you're
is wrong,
struggling
but I don't
with
know.
this.
Wait, no, no, no.
That was
I mean,
many
science-
chapters ago.
I know.
Oh, sinus and stuff, right?
Yeah. So it's the science.
And then you need negative cosine.
Where'd you get the three?
The inner
Chain rule.
Well, that's where that three came from.
Yeah.
Where did that
Yeah,
come
we-
Oh
from?
shit. No, because isn't it?
the inner derivative
That
was
three,
first.
When you-
So
that three is there. That three is right.
You're just
This,
copying
and then
it.
it's
this
gonna
three
be
is correct.
cosine
This
is
three
negative
is correct.
negative
That
cosine.
three is correct. That three right there is correct. Where the heck that three came from?
Oh, sorry,
Yeah, yeah.
sorry.
And that was
This
Sorry.
is my answer.
It doesn't matter because like.
The cosides can cancel out.
Sorry, I just forgot, but like
But the
yeah.
three doesn't
How do you
cancel out.
isolate
So then the three stays. Okay, but it.
So figure out how that works with that.
Ah, shit.
Where does that three
Yeah.
go?
I don't know how to do that.
So
I thought you said you were
I heard
three.
you talking to like someone else saying that like the 10 we would deal with
Man,
later.
that was
Yes.
right.
Right.
Dude, so
But
it's D
where do
over
we put it
3.
for now? So obviously
Okay,
like
that's-
Well,
this,
replace the
So
sign.
can't you just
this
move
would
that
be like
What would it become?
wouldn't it be just d
over 3?
We can say
Yeah.
3x.
U to the what power?
Holy crap! Hold up, I gotta change it over.
It's like the other power.
No, but we
When
haven't
replace the
answered
sign
the
around it,
You over this?
the power's kind of.
Can't you just do this?
Right here. We're solving for dx.
Oh yeah, and then
Basically, and then just put it all
Yeah.
under 3.
This
Yeah, but then how was the substitution?
And then what is
Find
your
the
du?
integral.
du
Oh, our
equals-
du is 3.
Can it just be u to the 11 over 11 over 3?
No,
Yeah,
it's
but
not.
wait, no.
No, that is du.
You just said it was
And then just
over
times
here.
it.
du. Sorry, it's du. We have to find u.
So what if we times 3 right now?
Does that make sense?
No, but that would be more people over there.
It's not gonna go this hard.
It equals u minus
It's
r.
gonna do this.
du is the
Like, you know
Because
this
you do
happened.
u to the 10 du.
Oh, because they're multiplying. Because they're multiplying. Well, these are multiplying.
So then now we have to isolate
Each other.
Right. So what you're saying is you multiply them to each other right now.
So then
Yeah,
it's
so
gonna be
basically
u
we're
to
gonna
the
transfer everything that we put a dx.
Yes, and now find
I didn't understand how to get it.
when du is this.
So that's why that's not gonna work.
Because du, you're just taking the.
That's the idea behind the use.
Like what's the integral right now? Because since du is integral to 3, I don't know how to deal with it.
It's not gonna keep going.
Wait,
Damn, this is a lot of steps. I actually feel smart though. No, I should be. I feel like.
Is it? Oh, yeah, it is.
Oh.
That's probably why it's this.
Yeah, why? Huh? You don't know? Wait. I think so. Sorry, I was just kind of like confused at what you're asking.
So what if you multiply by 3? I think
I'm just saying, like,
Or
maybe
you
it
can do
should be
the,
like
or you can include the C.
this, but I don't know.
It's a coefficient
Who's
of
that?
your integral. If you do coefficients of integrals, like if it was. Okay, but this is what I got. We're close. Yeah, actually that's not bad, but there's something questionable. If you're gonna integrate it, you got that u
And
to
then
the
we
11th
cancel
over
out the
11.
negative.
There's no more du. Because you just did the antiderivative.
Yeah. Because it plays into
Like,
dx.
where's your integral signs? Your integral signs need to be there until you do the antiderivative. Yeah.
Yeah, let me rewrite it
That's
too.
right.
even when the du is there.
Yeah.
Yeah, because the du doesn't. You're still taking the.
Well, yeah. And then replace the u. You should be good.
That's it. And I'm right.
Yeah.
That's right.
The
Wait, so what
function.
did you do?
I basically what I told you I did.
Yeah.
The du,
it's
you're still
correct.
taking the antiderivative of this.
Oh, that looks so
Because it doesn't matter if the du is right next to it. Doesn't
Root
matter
of the
because you
sign
can
is
still
not
move that
negative
du
cosine.
like that, like right next to it.
Almost
And you're
10:30.
still taking the antiderivative of this.
So they can go to 30.
But it's the u to the 10, not the 3.
Lila, was it upward bound?
Yeah.
So, oh, and then it's adjusted. And then that's how you divide it over. And then
Take out that u.
yeah.
Yeah.
Hey, knock me. I didn't think it was
It's just
that
cosine.
easy.
It's cosine.
Yes.
Wait, so we're just finding the derivative.
Alright.
Okay, I'm done.
And then the cosine 3x cancels out.
Wasn't that bad?
Let's do this. Let's do this before
That's a lot of steps.
Wait, Lena.
you rewrite the whole problem and then substitute dx for du.
Did you get over 4?
Yeah, because. Huh?
Did you get over 4? What was your final, like,
Sine 3x to the 11th, all of that was
like, without substituting, give me like what you got before right now?
u to the 11th over 11th over
What's your
3.
u?
Why is that?
Oh, yeah.
You just have to take the antiderivative of u to the 10.
Oh.
What'd you get, Lila? What'd you get for the second one?
It's okay.
Oh.
Wait, did you have du over 3 steps?
This is why knocking is wrong.
And you have
Right.
All right.
Wait, don't.
U times.
Because that's
minute.
you.
Let's
The sign.
I'm like on the
one.
verge.
Let's go 30 seconds.
30 seconds. A minute.
30 seconds. I'm sorry. 25 seconds. 20 seconds.
But what about the four? Basically, or not the forms. I'm
I
sorry.
see.
15 seconds.
I did it.
Oh, yeah,
I see
you're
what
right.
you said.
Wait, okay, so
10 seconds.
U to the power 10.
Oh my gosh, not me.
Yes.
Okay, now what?
I don't. You
5
have
seconds.
Antiderivative integral. Yeah.
That's not even.
All right, pause there for a second.
No.
Come on. Bring your attention back up here. Let's take a look at these problems one at a time.
Yes.
Okay.
No.
Don't worry if you didn't get it all the way through. We're going to do more problems, okay? Integral techniques is where things get interesting. Derivative techniques, there was a lot of them, like product rule, quotient rule, chain rule, yeah? Integrals are a little bit different. They don't have like a straight up, yo, that's clearly product. It's not as straightforward as that. But for u substitution right now, we're focusing on the fact that you're going to let u equal to something for right now, yeah? So for example, right here, hopefully you saw that 6x squared is clearly the derivative of 2x cubed, yeah? Now, if you let u equal to 2x cubed and only 2x cubed, du is going to equal to 6x squared, which is nice, right? But here's my issue. I don't want to deal with u plus 1 being raised to the 4th power. You get what I'm trying to say? U plus 1 to the 4th power, that's annoying. Whenever you have a plus something and then you raise it to a power and you expand that binomial, that becomes monstrosity, right? So why not just do this? Let it equal to the plus 1 at the very start. What happens when you take the derivative of the plus 1? It just goes away. So that means now I can replace this entire thing. You see that? With the letter u. So I don't have to deal with plus 1 being raised to the 4th power. This is going to be a dx again because I'm cheating. All right? Step 3? Or is it still step 2? I think it's still step 2. Find du, step 3. Find du from part 2 and then isolate dx. So there's dx right there. I'm going to isolate it by dividing both sides by 6x squared. So I end up with du over 6x squared is equal to dx. That is going to be what I'm going to replace my dx with. Yeah? So I have all this stuff now set up for me to replace the dx and this 2x cubed plus 1. So this is going to become the integral of 6x squared over u to the 4th du over 6x squared. The 6x squares cancel. I'm left with this, which is the integral of 1 over u to the 4th du. This was the pause or the friction point that everybody came across. How to antiderivative this fraction. This is no longer a u substitution issue. This is now an issue of rewriting your functions into something that you can integrate. That's a technique. The main thing that we've dealt with is always the power rule. If you can get it to look like x to some power, it doesn't even have to be positive, it could be negative. This rule still applies. The only one it doesn't work for is if it was x to the negative 1, yeah? Because x to the negative 1 would be 0, and then we know that just fails. So, anyways, we'll deal with that when we get to it. But for right now, this is going to be equal to the integral of u to the negative 4 du. That's the rewrite I need, yeah? Understanding that x to the negative 4th is the same thing as 1 over x to the 4th, yeah? That's the technique we needed to get from here to here. Now that I have like this, can you do the power rule? Yeah. When you do the antiderivative, that's when the integral disappears. You need to get into the habit of constantly writing that integral sign until you do the antiderivative. Once you do the antiderivative, then it disappears. So antiderivative of this will be u to the negative 3rd over 3. Yes? No, oh yeah. No evaluation, right? So that means this is going to have to include what at the end? Plus c. You have a couple options at this point. You can just go ahead and substitute back in. This will become 2x to the 3rd plus 1 to the negative 3rd power over negative 3 plus c. I'm perfectly okay with that. If you had went ahead and rewrote this as 1 over negative 3u plus c to the 3rd, like that. You could do it that way as well. You'll get the same answer. This would be 1 over negative 3 times 2x to the third plus 1 to the third plus c. These two are the same thing. Just one's in the top and one's in the bottom. Yeah? Which one's more correct? Both of them. Which one's more likely to show up on a multiple choice question?
Oh, really?
Math people, for some reason, don't like negative exponents. And math people also don't like fractional exponents.
Oh, wait, I did that anyway.
So if you did fraction exponents, instead of it being like x to the 1/3, they prefer you to write that as the cube root of x. Does that make sense?
Yeah.
They're the same thing. I just, one
That's what, yeah.
cares more than the other. Anyways, how does that feel?
It was alright.
Not too bad? It was kind of a lot. I'm not going to lie to you. It was kind of a lot. But once you see it, right, it's not too bad.
Right.
Move that over
I
here.
got the second one.
Oh, let's talk about the second one. Do you still need the first one?
I think my problem is just remembering not to solve after I get to like the actual plus C.
Which is not a bad problem to have, because at some point later we are going to have to solve for that plus C.
I got the answer, but I continued to solve it. And so I was like, oh, I got a chain rule. And I tried to continue to solve
Oh, you went to take the derivative of it and chain
and I was like, and
So,
I got like this super big number.
so when you took the derivative and you chain ruled it, you're just checking your answer, pretty much.
Oh, okay.
So if you take the derivative and you chain rule it and you do it correctly, you should end up back at where we started.
Okay.
That's the idea. Because we did that over here. That's probably why you were doing it, because
Right.
we got this answer, I boxed it, yeah? I took the derivative and chain ruled it because I wanted to check, does this match with what we started with? Which it did.
And the derivative of the answer would be the original problem. Right?
Yes.
Okay.
Yes. If you did it correctly, it should be. And yeah, if you chain ruled this right here, it should give you that. All right. So enough of that. Let's come over here. Take a look at this problem. This one's tricky. How many functions do you see?
2,
4. I mean 3.
4.
4.
There are 4
Oh, 4,
functions.
sorry.
Oh yeah, the sign.
You got a sine function involved. You got a cosine function involved. You got a 3x function involved. There's one more.
To the
10.
10th.
There's some stuff to the 10th power. And that stuff to the 10th, by the way, is sine of some stuff to the 10th power. 4 whole functions in there. How do you figure out what should you let u equal to?
I set u equal to sine 3x because it's the derivative of cosine.
U equal to sine 3x. I would agree with that one. Look at it closely. What do you notice? We got cosine and we got sine, right? If you're having trouble seeing this, what helps me is I hate powers that are written like this on a trig value. I prefer to write it out like this. Sine of 3x to the 10th times cosine of 3x. That makes it easier for me to deal with it. That 10 is annoying to look at when it's in there, but it's the same thing. It's just personal preference, okay? I write it like that so that way when I replace sine of, replace sine of 3x, I see where it goes. Do you see it?
Yeah.
It's going to go in there. Whereas that 10 right there is just like, what the heck is that 10 doing? You know what I mean? It's the same thing.
It
Don't.
felt kind of illegal to do that.
Yeah, I know. It's weird, right? Again, this is a personal thing for us. Most people would just say, get over it. Now, are you okay with that? Why did I go with the sine? I could have easily went with cosine, because the derivative of cosine would be negative sine. There's no negative, that's one thing. But we could always just include a negative to balance it out. But I think the bigger thing is this. I'd have to deal with that 10, right? And if you notice over here, what happened with the 6x squares? They cancel out. So what's going to happen here is if I had gone with cosine, I would have got a sine to cancel out with just one of the sines. I don't have 10 sines to cancel out, right? So it wouldn't work. It would only cancel out one of them. I'd be left with 9 of these sines, and I'd be screwed, right? So this is a workaround. So I don't have to deal with canceling out all 10 sines. I just have to cancel out one of the cosines. See that? All right, a lot of talking for nothing. Let's go ahead and do this here. Derivative of both sides. We get du. Did you chain rule this derivative? Derivative of the inside is 3.
Cosine of 3x.
3 cosine of 3x. Very good. Dx, of course, yes? Solve from both sides. We end up with du over 3 times cosine of 3x. That's equal to what?
dx, sorry.
Yeah.
Hold up, what? Oh.
So that dx right there is gonna replace that dx right there. Yes? Let's go ahead and start substituting here. We got here the integral of u to the 10th times cosine of 3x times. Good.
Cancel out the cosine 3x.
But the 3's still there, isn't it?
Yes. So it's du over 3.
Good. If you don't like it, and because it's annoying, write it in front.
Oh, you can do that?
3
That's
du.
what I didn't know.
Well, I can't take the du out. I can take the 3
It
out.
would be 3 times du.
Close.
Negative.
Du over 3. Yeah, there you go.
Oh, I just put the derivative as
Isn't that the same thing? Yeah?
So the derivative is just 1/3?
What do you mean by that?
Like, because when I did it, I didn't do that. I just took the derivative of it.
And then put it over 3? Or put 1/3?
Put it over 3.
You can do it that way. But I'm going to put the 1/3 in front. This is the property that's actually being used.
Oh, shit.
I
Okay?
didn't even know we could do that.
Oh, it's the point.
You see, that makes it so much better.
That makes it so much easier to solve. I didn't.
I didn't see that.
Oh, I left the 3 there.
You want me to show you
We
this?
did the more complicated.
You want me to show you the steps to get from there to there?
We did the more complicated.
So I did the
way.
integral of 1/3 u du. You okay with that?
Right.
And then, since that's just a coefficient, I just move it to the front. We could do that with integrals, as long as there's no x's or u's or any other letters, right?
You know what's so funny? Being in calc really makes you realize how like dumb we
Easy
low-key
life.
are. Like we low-key could have did that, but like we were like, no.
Let's do a more complicated way.
But if you leave it in there, is it really that much more incorrect? No, it's just more work for you. You end up with a fraction over a fraction, which, by the way, simplifies to the same answer. Because I'm assuming you did it the other way, where you had it and you came out with this. You probably came out with u to the 11th over 11 over 3.
Yes.
Yeah.
Yep.
Simplify that for
It
me.
didn't seem
Wait,
that bad though.
no.
U to the 11 from. Oh.
1 over 11.
Mitchell.
My final answer was just sine 3x
Literally what we
11
did.
over.
So what do you think? What do you think that'll simplify to?
It's still right, but like we just did it more complicated.
This will be u to the 11th over.
It wasn't much, but
Anyone got it?
33.
Yeah.
Not bad. Or bad. That was right.
oh, do
So-
you have?
No, you can leave it like that, but that's ugly.
So it's
Oh, I did.
I'm just saying though, if you deal it with this way
I still did it right.
instead, it's a little bit easier.
No, but you were so close.
So, what's the antiderivative of u to the 10th?
U to the 11th over 11.
Over?
11.
Good. Plus c. Yeah?
Yeah.
Simplifying this, how do you multiply fractions? Straight across, we end up with u to the 11th over 33 plus c. Oh,
Got rid of that. It's good, but I got rid of the 3.
I just feel.
we can't yet.
I just erased it. I was like, "Me too."
Now I realize I could have solved this in like 3 minutes.
It's okay.
Not 10. You know,
What's the u equal to in the beginning?
sine of 3?
So sine of 3x, this whole thing is being raised to the power of the 11th over 33
Plus c.
plus c. That's my answer. You ready for the kicker?
What's the kicker?
This was
the
the
kicker?
kicker.
No, here's the kicker. If I take the derivative of this, what's going to happen with this 11? It's going to go down, so 11 is going to come in front and it'll cancel out with 33, right? So you end up with 11, and that will become 3. What's the derivative inside?
3.
That's annoying.
You can just figure it out like
You see that? So then this would have been sine of 3x to the 10th because power rule.
Oh my
What's the
God.
derivative of this inside?
Cosine of 3. 3 cosine of.
Yeah, but what happened to the 3 earlier?
It gets canceled out.
So it just.
Cosine of 3x.
So did you notice that the derivative of this
That's irritating.
is what we started with?
That is so irritating.
We could just do that, right? Can we just do that?
Yeah, but how many of you are going to be able to see that in your brain?
I'm not, you know, if I do it enough,
I'll
maybe.
force my brain.
Some people do. Say it one more time.
Oh, wait.
The 3 on the.
I think.
So here's the thing. I did a multiple derivatives here. So I took the 11 out because that's the derivative of that power rule, and that would come down in front, right? And then do the derivative of this inside. What's the derivative of 3x? And that is going to cancel out with everything that's down here. That make sense?
That is so
You okay?
Yeah.
Not too bad?
Yeah, you should hit us with like an even harder one.
Yes, hit us with a harder one.
What does that mean, even harder one?
Hit us with a hard one.
I'll hit you with a weird one. How about that?
Weird is gonna be hard.
All right, so did you guys get that copy down, though?
Yeah.
Does anyone need
But
it?
it's okay if I leave it like the fraction over
Yes.
the fraction.
Just know that on the multiple choice section,
It's gonna it might be different.
it won't look like this. It'll look like that. Okay? So it's not going to look like 11 over 3.
Okay.
Because mathematicians just don't like fractions on fractions. Yeah, I don't really like it. I like it like this.
Well, each one doesn't matter to me.
All right, so we good? Do you guys copy it? Did you take a picture of it if you didn't copy it?
So,
Mm.
with that shortcut thing,
What shortcut thing?
where 11 goes to the front, why is 11 more than how you?
Because you
Coefficient
changed.
J?
Derivatives. So here's the thing. If I gave you, and I asked you, take the derivative of sine of 3x to the 11th power.
Oh, I'd be like, it's
There's a inner, there's a middle, and there's a outer. Right? Inner is 3x, middle is sine of some stuff, outer is some stuff to the 11th power. When you do the derivative of some stuff to the 11th power, 11 times stuff to the 10th power. That 11 is the 11 I was trying to show down here. That cancels out with the 33. Yeah. Okay. New problem. Let's have you try this one. You ready? Or, yeah. Do you want 2 problems again or just 1?
Unless you need to move on, but if not.
No, I think you guys need to practice.
Yay.
Cube root of
Never mind.
3x plus 1
I don't like.
dx.
Why is it number 1 and not an example?
Okay.
I know. I
Okay.
don't like that. I
Okay.
don't like that. Put example, please.
Okay, example.
You guys are extra.
No, because
It's just weird.
I can't tell if it's like a new lesson, if it's like a new concept, like, you know.
Shut up.
Numbers are arbitrary.
If Matt says it, we're cool.
Numbers are arbitrary.
damn.
They're just random counters for different
So
problems.
glad your month is over.
Wow.
Whoa,
Wow.
Lila.
Did you just hear that racism?
Whoa, Lila,
Now
you
that
never
came,
told me.
I agree with you, Devin. I agree with you.
Doc is ready to go. Stop the recording.
I feel offended.
I felt offended.
I'm black too, Lila.
It hurt, like. Wow, Lila.
I'm gonna step out real quick.
Women's History Month, Lila. That's how you
But
treat
Anita,
us?
you're an
Wow.
exception. Devin's not.
It's not women's issue. Women's empowerment.
Wow, man, that's crazy.
I thought it was women's
Got it.
history.
All right.
I thought it was empowerment.
Try this problem.
History, empowerment.
Okay.
It's Women's Month.
Yes, it's Women Empowerment Month.
Yeah,
History Month.
Empowerment?
Then why did Mr. Sandoval have me make a poster that said women's history?
Because you're making.
It's Women History.
Typical man who doesn't know.
But the club is called Women's Empowerment Club.
Because it's
Join
Sandoval.
it, please.
It's Sandoval.
All right.
It's Sandoval.
Woman's.
Oh, I see. But you're an ally.
It is Women's History Month in the United States.
I
Yeah,
thought that.
I give up.
You gave up? You haven't even started.
What I did
Yeah.
was.
Don't give up, AJ.
I put you as 3x.
Hey, don't
Oh,
say it. Don't say
okay, yeah.
Don't say it.
Keep going. Keep going.
And then I just left the 1/3
Why is it
alone.
though?
Keep going.
Because I changed the what's it called to 1/3.
Keep going.
There's no way 14 is.
There's no, right, I'm about to say, there's no way
Why is
3x,
this
Then you can take that.
3x
You know what? You know what?
plus 1 to the 1/3 power equals 14.
Equals to 14. That's what I'm saying.
There's no.
It doesn't. And that's going to be okay.
Why?
How? It's not okay.
I thought you said it has to be like derivative.
All right. Do you want me to hold your hand to this one?
Yes.
I'm listening.
No, that's not
No,
for you. That's
hold
not
my
for you.
hand.
Unless you have to do some kind of
Save that one more power to 14.
Okay. How about this? How about this?
I might as well go with neither then, because somebody holding my hand.
I'll give you a minute to at least get what you think U should equal to.
I just need to know why
You,
it's okay
you
for
should just try.
Oh, 'cause
Get into it and try.
What did you say?
No, try it.
I said that the derivative
There's not many options here.
there's no way 14 is ahead.
I know, but he said that's okay.
But he
But
said
why
that's
is it
okay,
okay?
but why is it okay?
It's not
Right.
okay,
Why
not
is-
me.
I want to know why it's
Oh,
okay.
if you change it to a fraction.
If the derivative of that big over it, denominator of 14. Someone do the work and verify.
No, you.
I like it. All right, you came across a theory. I like your theory. And you're like, I'm not gonna test it. Someone test it.
Yeah, please, Lana. Like do the little math, right? Come on.
What?
Take the derivative of the denominator.
Yeah, handling that.
Bro, it's way too loud.
Inner equals
It's not 14.
3.
It's not 14, is it? It's 9
Not me,
x
not
plus
me.
1.
So you do X plus 1.
How is that 14?
It is.
Why does
This
it
has
feel
something
so
to do with
fake?
Q.
Okay, we got it. Next
It feels so
X,
fake.
then
Like it's so
dx,
light.
dx, right? So we solve it.
Wait.
You.
We add plus 1.
DU is 3.
Yeah,
Over
D.
there.
Okay,
I
wait, can I try this?
And then we get rid of the 3.
I have this math packet in my photo.
Make it a fraction.
Wait.
Come on. Don't just sit there. Write. Write it out.
Okay, we're gonna make it a U, so that way after it's gonna be 1/3, and then it's gonna be
Okay, well this one cancels out. Just 3 over 1 times 1 over 3 is 3 over 3.
How are you giving my times up for my phone?
Times up.
So then I plug it into dx. So it's du.
I got you.
Hey, why didn't you do the chain rule? Why didn't you change it to U?
Because,
Q
I'm
is
doing
1
that,
over
I
3,
just
right?
cancel it out so I can see it. So then it's just x plus 1.
When you do the chain rule.
Can I put it into a
It's
fraction?
gonna be u. It's gonna be u. So yeah, you're right.
Okay.
Now, do you want to know something so frustrating?
14 over u.
2 years ago.
I don't know how you got
2 years ago, I showed Natalie this song. It was a good song, like a very popular mainstream song, and she said she didn't like it. About a month ago, she's like, I discovered this amazing song that I think you'll like. I listened to it right away. I knew it was a song that I showed her 2 years ago.
You know what's crazy? It sounded like she grew
Yeah.
in 2 years, and her opinion of that
No,
song
okay, it's just,
changed because she grew as a person.
but she said she discovered it. She was hating on the song so much.
I genuinely forgot. Like, she
And that's fair.
So to me, it's like,
If you didn't like it to begin with, why would you remember something you don't like?
But why is she?
We're gonna do this problem. Come here.
How do you do that? Is it
Yes,
2
Pop.
over 3?
All right, I promised you about 2 minutes. I'm not gonna do the problem, but I'm gonna show you this hand holding part right here.
Oh. Well, we know that.
That's what I would start with.
We have that.
Oh, you did?
Yeah, we
Oh,
have
all right, I got you. Then you should at least get to here.
But I want to know why.
du equals 3.
Not me. How do you write the
That's
radical?
just all I want to know.
Is it,
And I can do the rest.
Is it some stuff to 2/3 or 1/3?
Not me.
It's 1/3.
2/3?
1/3.
Okay,
Told
yeah,
you,
okay,
I
1/3.
told you.
We knew it, but I was just.
No, you
no,
have
no,
to-
no, no,
No,
no, no.
but then you still have to do the.
No. Oh,
I thought it was
I'm
1/3.
telling you,
Time out.
it's
Time
1/3.
out.
Time
Time
out.
out.
There's no time
Not me.
Which 3? This 3?
Just me. Three?
That 3?
Yeah. How do you
What's the derivative of 3x?
Yeah, not me.
How do I what?
I don't think I'm.
I just want to know why why is it. I just rewrote it.
Oh,
So
oh my god.
3x.
I hate it, bro.
I honestly don't know that it's 3x plus 1.
So how are you supposed to
You try it. If it doesn't work, then we try something else. Huh? You just have to try it. I know you're like, that 3 doesn't match with that 14. That's okay. You just try it out. Let's see what happens. Work it through.
Wait, don't you need the.
That's why I just turned that into a U, and then I put the
Yes. Yes, it does not cancel out.
But it's gonna have a derivative.
It happens.
Okay, hold up.
Okay.
Esther, you're not gonna try it? No. Why not, Esther?
I'm not
One third.
I'm gonna play a game with myself.
Oh, you process.
So we can do two-thirds. One
From
over
the original
Wait,
one,
wait,
and some
Yeah, you
converting
can
the.
just do like that. Times du. Oh, you multiplied it.
Yeah, I cross multiply.
Got it. We're gonna do that instead. I was gonna do the complicated.
I'm just letting y'all know I'm not calling you
But wait, are you killing puppies?
This is the anti.
No, he's not killing
No,
a puppy.
no, because this is just simplifying. It
Yeah,
doesn't have
he
to
can
be
do
right.
that. But this doesn't
Oh,
equal
yeah,
negative
never
3
mind.
though. It'll be
Oh.
1 over 3.
Yeah,
You're
yeah.
right,
So
you're
it'd be-
right. Okay, that's it.
Wait, you.
Yeah.
These?
You can add
Oh wait, no, that's a 3 in the top. I'm stupid.
Are you adding it or are you
Wait, why did I put a
you-
14 under here? It's supposed to be a U.
I'm not gonna cross it.
You're,
I don't think you can cross
Oh,
it.
yeah.
yeah, that's why. I'm looking for you.
Yeah,
Yeah.
I'm gonna sound like that.
Okay, so now you take the.
You got me confused.
I just changed it back. I changed it back to
Can you put the 3?
then you take the antiderivative for
No, but I'm gonna get 14 over here outside and then put that.
No, I'm gonna put it out for the du first. So just
Not the 18 U?
you understand? So it's gonna be 14 over.
Okay. No. Pause.
You
We
greater than
move
3.
this. We move this out.
Yes.
Yes.
Yeah,
One third,
exactly.
and then right
Can you
after
do
it
that?
comes
Not
divided
the
into
14.
one third, and then.
Like,
Yeah, remove that out.
Wait, I don't know. Can we
Let's see.
do it like that?
Hold on,
Like,
hold on, hold on.
change it to that?
I don't think it's 130.
Hold on, let me go back
No,
to
but
the-
it's a coefficient, right?
Derivative.
Derivative.
Oh,
You
yeah.
plug it in.
No, derivative. Then
Oh, that 1/3. Yes. But what happened to the cube root is what I was saying.
We use that.
Okay,
Don't we use that for?
Okay, derivative is
Let's
no.
do that first.
So you know the first one I had was that was the derivative.
Close. Your 14 disappeared.
Oh!
1/3 is fine.
That's the derivative. I forgot. So
Because you were solving, I was like,
yeah, I was solving it. So our new derivative now
What's
is
the thing look like?
Where's the
So, by the way, I love the you took the 1/3 out. That was right here.
and then
You could have also taken the 14 out.
1/3 was and so it's 1/3.
what is happening?
Two
Just be
over
left with
three.
one
Over
over.
2 over 3.
1 over.
You ready to get your mind blown?
No, it's gonna be like this.
No. I did mine like this. So 1/3
Whoa,
u
that's a whole lot
2
of
over 3 over 2 over 3. Because
Unless
if
you
Would
just-
you not
add it
agree
to
that
one
it's the
top?
same thing as
well, if you
14
do
over
the
3?
chain with derivative,
Yeah.
no. I'm not.
Oh no, but you still have to take the.
Man,
I'm
I
asking
didn't
you.
realize you
Add
had
the one on this
such
one, so
a
then
crazy like.
what's u plus?
That's what I'm
U
saying.
Sense of fractions.
one.
If you do this,
What's
I
it-
don't
1/3
know.
I think it's because
One
it's
third
dealing
plus one
with fractions.
2 over 3, right?
2 over 3.
Okay, so then you're gonna use the u 2 over 3 and then
Over 2 over 3.
over 2 over 3.
With the 14 go.
I just did the derivative of it.
Why'd you do the derivative of it?
Not the
You take the
derivative of 14.
antiderivative of 14? But this is right so far, right? We got this part.
So far, yeah. But
Okay,
So
so-
like,
I
if we
want
can
to deal with
the
the
bottom,
14 when you do the answer.
So then how do you do that?
easier to find the antiderivative.
Well, then we just take the derivative of the bottom part of the u.
Where'd the 14 go?
Hey, well,
It's still
we're-
right there.
It's still right there. We're just like
It's not numerator.
Oh,
We're
okay.
focusing on the denominator.
Yeah, we're focusing
Oh, okay, so what you got there? Is you do the 1/3 denominator?
So I
So how would
have
that be?
1/3
But it's only- it's mostly with
to 2 over
fractions,
3rd
though.
power.
Third u to the.
Where's the
2/3?
14 though? Like,
Okay, so if we simplify.
14 over.
Bottom.
That's good. Okay, but I'm still confused as to
Listen up, we're all confused.
What we do?
what are you doing there? You're just going straight from u to the 2 over 3?
Okay, so I took out the 3 from here, right? So you see how I took out the 3 over
Right, put it aside.
I just don't know how to do that.
I don't either.
Would that just be?
You mean the antiderivative?
Oh,
Let me clean it up. Let me
Oh,
clean it
yeah,
up.
Is
yeah,
it
yeah,
u
yeah.
over
You're taking the
over 2
integral.
over 3? Is it u to over 3 over 2? 14?
I don't know
No,
if you
why
can
is there
just
next
do.
now?
Because your antiderivative, right?
Because it could be negative.
See, that's the issue.
1/3.
You're trying to do the antiderivative of something over something.
I think we can.
We don't have that technique. We only have power rules. Maybe you should get into a form of a power before you do the antiderivative.
Oh! Fudge cakes. Okay.
Okay, that makes sense.
That
Let's
makes
separate it.
total
Let's separate
sense.
it.
That makes total sense. So 14.
Yeah.
That's easier to
One,
You do the
u over
antiderivative of
1/3
this,
is
which is this, which is that,
u
which
is
that,
u
which is that,
with
which is
five.
that.
Um.
that,
Oh
which is
yeah,
that,
wait.
looks
Okay,
cute.
wait.
Would you want us to make it this?
Like that.
14 times. Is it negative u to the 1/3?
Where's that 3 coming from?
I think it's yes, no, negative u to the no,
Wait,
u to the negative I don't know.
Yes, u to, no, u to the negative 1/3. Because you, it's already in this way. All you have to do is
Shouldn't it be?
why would it be? Because
it's a fraction.
It's a fraction.
All right, let's take a
All
look.
you have to do is flip it.
Okay.
You don't have to do it.
All right.
You just flip it. U to negative 1/3.
Okay. Focus. Bring it back. Bring it back.
We're almost there.
Bring it back.
I know we are.
Bring it back. I
Okay, then we plug it
think I've spotted your issues.
Our issues, we have many.
Yes, but one big one. All right, check this out. Focus back up here. Look, some of you guys are pretty close, but okay, let's do the substitution here, right? We know that u is equal to that, so I'm going to replace that with the letter u. So I have here 14 over the cube root of u, and then instead of dx, I'm going to replace it with this, which is just what? du over 3. All right, don't limit yourself on these fractions, okay? Maybe you should see it this way instead. Write this as 14 over 3 times 1 over the cube root of u, du. Some of you guys are freaking out. Yo, that 3 doesn't cancel out with that 14. You're right, it doesn't cancel out. You should only panic if there's still an x remaining. Is there an x still there?
Close. Not quite.
No. Even though the 14 didn't cancel, I don't care because there's no x's to deal with. Okay?
I'm confident in our
Now.
We still did it right.
Now. 14 over 3 is just a coefficient, just like 1 over 3 was, or just like 1 over 4 was, or just like 1 over 10 is. It's just a fraction. It's just a coefficient. It's a number. That coefficient gets to go where on your integral?
in front.
So we can deal with that later. Now we got to deal with the integral of 1 over the cube root of u du. Convert it what into a fraction?
the cube root.
Good. So this will be 14 over 3 still on the side right there. Rewrite this as 1 over u to the 1/3 du. I'm still not okay with this because it's 1 over instead of just the power by itself. What can you do with that power?
We overdid.
What should the power become?
U to the negative
1/3.
1/3. Yeah.
So rewrite it one more time. We get the integral of u to the negative 1/3 du.
Oh, we incorporate that.
1 over x is the same thing as x to the negative 1.
Yeah.
1 over x squared is the same thing as x to the negative 2.
Yeah.
1 over x to the ridiculous power,
Is that times?
it's
that.
x to the negative that ridiculous power.
Reciprocal.
We have ways to rewrite these things as powers, right? And you want to do that because you want the power rule. It's the easiest way to do the integral. Okay?
Because a fraction is bigger.
So this is my power rule, right? What's my power?
Negative 1/3.
Negative 1/3. So this is going to become 14 over 3. Do the antiderivative of this. This becomes u to the negative 1/3 plus 1. What's that?
Negative,
Two.
negative 1/3 plus 1.
2/3.
2/3. All over 2/3, right? Have you guys gotten a shortcut for this yet?
Yes, you take the inner and the outer.
No. What? No.
No, it'll just be 2. It'll just be 1 over. 1 over.
Yes, I did too.
I had it somewhat like that. I
Okay.
just have the 14 over 3.
Let's do it one step at a time. You got this part right here. If I had x to the n, it becomes x to the n plus 1 over n plus 1. Yeah? That means this one right here is going to be u to the negative 1/3 plus 1 over negative 1/3 plus 1. Yeah? Negative 1/3 plus 1 is the same thing as negative 1/3 plus 3 over 3. Yeah? Common denominator. Yes?
Right.
What's negative 1 plus 3?
2.
over 3. Yeah? In the bottom, you have the same thing. Negative 1/3 plus 1, still 2 over 3. What happens with a fraction over a fraction?
Oh, it flips.
Keep
You're
the
right.
top, flip the bottom, multiply it to there. You okay?
Yeah. Okay. Got it.
Lila?
Got it.
Yeah, got it.
Lila, you okay?
But it's two.
You're not looking okay. Where did I lose you?
No, because we did it
Completely
differently.
different.
To where, like,
Okay, what if we do this? What if we substitute one?
unless we move the
X,
14 on the
we
outside,
just input a value.
it's the same thing. Because we did the 1/3 on the outside and 14 on the inside. Can we just move the 14
Yeah.
over?
Yeah.
And
You
multiply
could also
by
keep the
1/3?
14 there. That'll also work
Well, I
out.
feel like that's extra work.
It is.
It is.
So I'll
But
just
it'll
move the 14 over.
it'll work though. All right.
We input like an X random X value.
Are we okay with what I have written there?
I
Any questions on what I got so far, Anita?
So after you get the 14
Bef-
over 3 integral of u to the negative 1/3, you take the antiderivative?
Of this, yes.
Okay.
That's what the integral is. The integral is the antiderivative of whatever stuff is inside the integral.
Plus C.
Yeah, I'm not done yet. But any questions with what I'm up to so far is the question I'm asking.
So when you're doing when you have a fraction of a fraction, the denominator fraction will flip,
Yeah.
right? And then the exponent will also flip. Because it says 2 over 2 at one point.
2 over 2.
I think it was 2 over 3.
2 over 3? Okay, you
Yeah,
just messed
I was
up. Okay.
confused on that too.
Yeah. Is it okay now?
Yeah.
Okay.
Yeah,
Plus
yeah.
C.
2 over 3. Oh, okay.
You can put the.
Plus C.
All right. So Stephen was really itching for me to simplify this out. 28 over 6. Or if you want to just simplify it by canceling things out, I think it'd be easier if we just did this. Oh yeah, that's a lie. I'm sorry. Not 28 over 6. Boop, boop, boop.
7, yeah.
I saw 28 on your paper.
I forgot to flip the 2.
Gotcha. That's where I saw that 28. It was 14 times 2 is what you had. I gotcha. So it'll come out this way. We end up with just 7 u to the 2/3 plus c.
That's
Well,
it.
what's u equal to though?
Oh, u is equal to 3x plus 1.
That was a lot.
Oh, that's it. Oh, Mr. Knox.
If you want to see it in radical form, it'll be the cube root
Yeah, because
of 3x plus 1 squared plus c.
Will it be like that on multiple choice?
That's what it'll probably look like on multiple choice.
The radical?
Yeah. But this one is the one that I would say stop.
okay, I'm getting it.
That was beautiful. That was so
When doing the derivative of that,
interesting.
where would we get to the 14 over?
All those things would actually cancel. And if you do all that stuff, you'll just end up with a 14 in the top. You won't end up with a 3 in the bottom. You want to see it? So what would happen with this power? It would come down, right? What's 7 times 2 over 3? Yeah? What's the derivative of the inside?
3.
What happens with the 3's? What are you left with? Yeah, dirty, right? That's a dirty problem. All right. Ooh, look at all that work.
We did so.
All right, one last thing before I let you go. Do you always need to do u substitutions?
No.
No.
Yes. No.
Wait.
Yes.
Wait,
Not
substitution?
always.
No.
Yeah.
And it's with U's.
Yeah. What?
Yeah, do you always need to do a u substitution?
Yes.
No, because you might not always have a u, right?
Yeah. So, let me ask you this.
Yeah.
What if I gave you a problem that looked like this? Whoops. We could let u equal to x, but that ain't going to help us. We'll just end up with sine squared of u, which is still the same issue.
You can take the antiderivative.
Can you?
Yeah.
What's the antiderivative of this?
Why don't you just flip it? Why don't you
No.
flip it first?
Two negative cosine.
2 times.
Now take the derivative of cosine. You're going to get sine squared? Are you also going to get it in the denominator?
Cosine.
Why don't you flip it first, right?
2 times
Negative cosine squared x, it'll be a little.
All right, tell me what you think the answer is. Tell me what you think the answer is.
Oh, Mr. Knockley. Okay.
That's a lot of work to do in my
Negative
head.
cosine.
Yeah, it's a lot. That's why I'm like wondering as to why, Anita, you're trying to do this in your head.
So on a shortcut.
I know that we're
Negative
gonna make it big
squared,
two.
negative sin x
uh,
squared, and then we can chain rule that, right?
Sine x, negative 2, yeah.
Oh, you want to rewrite it like this?
Yeah, and then we can chain rule that, right?
There's no chain rule for integrals. You can take the derivative of that with the chain rule.
Okay,
I'm asking what is the antiderivative of this?
It's
there is no antiderivative.
Oh, there
we
is.
can really do like inner, mid, and outer.
You're thinking of the derivative. I'm asking you, what should the function be so that when you do the derivative, you end up with this?
Negative cosine.
So
1 over cosine.
1 over cosine?
1 over cosine. Oh, it's on the tip of my tongue. I know it.
It's
1
1
over
Two.
cosine x.
Wait, would it be 1x over?
That's the derivative. 2 cosine of x. Take the derivative of that. Are you going to end up with this?
Negative cosine x plus c, huh?
Nope.
Then where does
we're
this
trying to
come from?
figure out a function that equals the interval. That's what we're doing.
Yeah.
Okay.
So here's the thing. If it's negative cosine x plus c, take the derivative of this. What's the derivative of negative cosine x? That's just going to give me sine of x,
Negative cosine is
which is not 1 over sine, and it also doesn't have a squared.
Oh,
Negative cosine squared.
Is it cosine negative
To
2?
the negative 1.
Would it be positive cosine?
1 over negative cosine squared.
Would it be positive?
No.
Negative
Two.
cosine.
That's 2 right there.
Negative
Negative 2.
Two.
Is it negative 2?
Negative cosine to the negative 2?
Wait, hold on. I'm trying to think what. Yeah, negative 2.
One
It's
x
gonna be negative 2, so it's
over-
gonna become a 1 over
Wait,
negative
no,
2.
pause,
That's it,
pause,
that's it,
time
that's
out, time out.
No.
Is it 1x though, right?
Look, if you think this is it, when you chain rule this right here, you're going to end up with negative 2, yeah? Times cosine to the negative 3x times the derivative of cosine, which is sine of x. That looks nothing like that. Yeah? Pause for
I
a
want
second.
to take a quick moment to congratulate 2 of our Rockstar employees for their selection as the Employees of the Year for their group.
Is it even not?
Both of these
No one
candidates
voted for
have
me.
gone far and above the call of duty and have shown the most
You ready for this?
dedication and hard work to their school and their community. They were selected by their peers as a representative of the best that Lawndale has to offer.
Do you remember this?
So congratulations
1 over
to
sine is the same thing as
classified
what?
Employee of the Year, School Nurse Erica Davis. And congratulations to Certificated Employee of the Year, ASL Teacher Deanne Crosby. Congratulations, ladies, and thank you so much for being everything that Lawndale needs from you. And we appreciate all of your hard work. Congratulations.
Okay, but she's not a
Look.
teacher.
Look. Sitting there trying to guess the original function, you'll be there forever, and then you actually have to take the derivative to see if it ends up looking like that. That's going to be a pain. Instead, work with what you have and try to manipulate it into something that you might know.
And isn't...
Why did I rewrite 1 over sine as cosecant? I don't
1
know.
over sine is cosecant.
Yeah,
It is.
I forgot about that.
And then there's a square there, so it's cosecant what?
Yeah.
Now, do you know what the antiderivative of cosecant squared is?
Cotangent x. Negative cotangent x plus c.
You're done.
So you can just do that, right? Shortcuts. Wow, I would do that.
But see, that's the problem, though.
Will you know?
You can say shortcuts all you want, but did you know to rewrite that as cosecant?
So we need to quiz on all of that.
Math really
We're
upsets
doing
me,
you.
but in a good way.
That was
So,
fun.
U substitution is great. I love U substitution.
Good job.
But it's not
Fun.
always applicable, right?
Yeah.
That's going to be, I'm telling you right now, the hardest part of integrals is knowing what
Okay, I
technique to
like
do
this.
and what should it look like.